Right, this is Alex Merced from alexmercedcoder.com with another video where I'm exploring another programming language and learning the basic syntax. Again, the goal of these videos isn't to master programming language or to give you all the tools you need, but to give you enough of a start that you're able to teach yourself more. Okay, and this video we're going to start Kotlin. Kotlin is sort of we can think of it as sort of the modern day successor to Java. It runs in the Java virtual machine. A little history on Java. Java was a programming language that was heavily marketed in the mid 90s with the idea of write once, run anywhere. The idea was that there was this virtual machine, and this virtual machine could run on a Mac, could run on a Windows, could run on different devices. So instead of you having to write code that's specifically to Windows or specifically to Mac, you could just write code for this Java virtual machine, and then that Java virtual machine would run anywhere, which is still very much a thing. There's a Java virtual machine now. There's the Groll virtual machine now. Windows has their own kind of virtual runtime type thing. That's part of the .NET framework. So that concept became very popular afterwards, this idea of virtual machines that run a particular language. So Java was the main language that ran in the Java virtual machine. But then people were like, well, why don't we create other languages that compile to Java bytecode? So that way you have more options when you're programming for the Java virtual machine. And Kotlin is one of those languages that got created. And in recent years, it's become more popular. Started supporting Kotlin as sort of the alternative for creating Android applications. So before you had almost all Android applications were programmed in Java. And now everyone's like, yeah, how about we move to Kotlin? It has a more modern syntax, has a lot of the same idea, it has all like the good stuff from the old and a lot of the good stuff from the new. And I always find that interesting when I'm using like languages like TypeScript, Swift, Kotlin, these newer languages, how they've adopted a lot of the sort of the newer syntax norms. So when you learn their older languages, you'll notice like there's a lot of things that are very similar, but a lot of the things that change in the newer languages are very similar in the sense that like declaring your return types in a function after your parameters instead of at the beginning of the function call and things like that. Just little things. No longer needing to use semicolons at the end of each statement, and other things. So those things make life a little bit easier. You're not hunting for missing semicolons. Your code reads a little bit more intuitively depending on where you declare your type. If you're declaring your type after your variable name instead of before your variable name, there's all these little, and then also the type inference. Most of these language has type inference, which means when you declare a variable, you don't have to always say what type it is if you're already giving it a value. Now, if you're new to programming, probably none of that meant anything to you, and hopefully you're still watching. But let's dive right into it and I'll explain some of these things. So in every language, there are variables, okay? And well, always the best place to start is with hello world. So let's look up hello world. Here we go, okay? So, and the reason why is because you need to learn the function. Every language has a function that prints text to its console, which is heavily used for debugging, okay? You generally always want to be printing your variables as you go along to make sure your variables are doing what they're supposed to be doing. It's a good way to test to see what's working, what's not working. But in this case, it's print ln, meaning print line. So I'm saying print line hello world. So if I run that, it's going to print hello world to the console once it finally runs. Okay, there we go, hello world. So it works. But I don't have to print just a string. And you can tell this is a string type variable or value because it has a quotation mark. So strings are always surrounded by quotation marks. But I could also print an integer value, like 5. 5 is a whole number. That makes it an integer value. And it'll eventually just print 5. It's taking a while. Looks like REPL. And then, just so you know, I'm using this service here called REPL.it. It's basically a place where you can have pretty much a nice little playground environment to run any language and practice any language online. You can actually write full programs in REPL. I haven't done that in REPL, but you could. You can write full websites. It has a lot of really cool tools. Okay, so it can print 5. It can print a double or float, which just means a decimal number. Okay, nope. Let me bring that parentheses back there. Okay, just make sure that it prints it out. Cool, 55.3. So you can print out whatever. You can also print out expressions. So not just print out a specific value, but I can be like, what's the result of 5 plus 5? and it'll print out the result of that. It prints out whatever is inside there. So when you're using operators, it's going to determine that this is an expression that you want it to calculate. So when it's done calculating it, it'll should print out the number 10, as it did. Okay, so going forward, I'm going to put some more expressions in there since it's taking a little while to render each time. It does mention that its Kotlin REPL is in beta, so they're currently working on it here at REPL.it. Okay, so we do that. So you can do expressions, and you can do all sorts of expressions. Yep. Control E. There we go. Control X. So you can do expressions like subtraction. You can do expressions like multiplication. You can do expressions like division. You can do expressions like modulus, okay? And we'll come back to modulus and kind of how that works. But there's also Boolean expressions. So that's another type of variable or type of data point. And Boolean expressions mean true or false. There's two values, true or false, that's it. So basically, when you put a Boolean expression in there, it's going to return not a specific number, but either true or false. So these would be, a Boolean operator would be something like less than, greater than, equals. Is that number equal the other number? Okay, notice it's not two equal signs, not one equal sign. Okay, is it not equal? Is it, anyone I'm missing? Oh yeah, like less than and equal than. You can do greater and equal than. Now let's run these and see what it comes up with. But basically, all these operators are able to either create expressions, to express ideas, to answer questions, to find solutions to problems. That's what a programming language does at the end of the day. Okay, so you can see here, 5 plus 5 is 10, 5 minus 5 is 0, 25, 5 times 5 is 25, 5 divided by 1 is 1, and modulus 5 is 0. So what does that mean? Well, what it means, modulus, the way you got to think about it is the first number is how many slices of pizza I have. The second number is how many people I have to distribute the pizza to. But I can't give anyone an uneven number of slices. They all have to get the same number of slices of pizza. So if I were to give 5 slices of pizza to 5 people, how many do I have left? None. Okay? And what that tells you when you have a modulus of 0 is that the first number is divisible by the second number. So 5 is divisible by 5. So if I were to change this to 10, 10 is still divisible by 5, so it should give us 0. Because if I distribute 10 slices to 5 people, I can give each people 2 slices of pizza and have none left over. But if I were to make it 12, modulus 5, I can give everybody 2 slices of pizza, but I'm not going to be able to give them a third, so I'm going to have 2 slices left over. So the result of that will be 2. So that's essentially what modulus is doing. It's a remainder function. It gets you the remainder if you evenly distribute it. It's mainly used to figure out what numbers are divisible by what number. So to figure out, like, probably the most used function for modulus is to figure out whether a number is odd or even. And the way you figure out whether a number is odd or even is you just figure out what modulus 2 is. So 10 modulus 2 is going to be 0, so it's even. If 13 modulus 2 is 1, so it's not even. That's pretty much how it's typically used. But you can use it in all sorts of different ways. Cool. So that's like variables and operators that you have to kind of express the ideas that you want to express. But what if you want something to happen if something is true and not if something is false? You don't always want every piece of code running. So this is where we start getting into like if statements. And the way if statements work is you say if you have an expression. So we'll say 5 is greater than 5. If that's true, do what's in these curly brackets. If that's false, then we'll put an else, then do what's in these curly brackets. Okay, so we'll say 5, we'll just kind of set up a basic template here for if statement. Print line, this is true, if that evaluates to be true. And if it evaluates to be false, Okay, and I'm just indenting it. Just it's a good habit to always kind of indent as you go. Anytime you have a new curly brace, indent. It just makes it easier to understand the ownership of code and what code's running where. This is true. This is false. So is 5 greater than 5? No. So when I run this code, it should come back to me with this is false. Okay, and if it was true, it would run this code. But it's only going to run one or the other because it's either true or false. And let's see here, it's expecting something. I did something funky. Let's see here. 5 is greater than 5. Else. Okay, so basically I got it working. The only thing I changed was the break. So instead of having this extra line here, I got rid of those extra lines. So let's see here. If I add that back in, does it not work again? As you know, again, practicing and getting the syntax right is always part of the process of learning a new language. Got it. Okay, so it gets sense it's expecting it to be on the next line. So in that case, I get rid of that extra line, I run it, and it should work. Bum 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 bum. This is false. Good. Okay, so again, 5 greater than 5, and you can put that in any kind of thing. So if I did 5 equals 5, then it's going to be true. And again, we'll run it again just to show you that it's true. So the important point of like control flow, meaning being able to control like the branching of how things happen, is that this is how you make things more exciting. If you choose, if this is true, then do this. If this is true, then do that. You can create that sort of winding path that's like the choose your own adventure book from when you were a kid. Cool. But then there's also loops. So what if you wanted to repeat, if you wanted to test something to be true, and then just keep doing it over and over again as long as this thing is true? There are loops. Okay, so for a loop, what we want to do is we want to declare a variable. So the way you declare a variable is you're going to use the keyword var. Let me just double check and make sure that is the case. I'm pretty sure it's var. Yep, var. Okay, it tends to be the standard variable syntax these days. Var I equals, and you can name your variables whatever you want. Generally, you should name them something that kind of tells you what it is, but we're just practicing today. Var I equals 0. So then the way a while loop works is that you're going to put something in there. So in here, an expression, as long as it's true, the loop will literally loop the code over and over again. So while I is less than 5, okay, and then we put curly brackets, and anything in those curly brackets will repeat over and over again until it's true. So we'll say print line. That's just going to print the variable I. Okay, and it's just going to keep, and then after each time, it's going to take that variable I and basically make it equal to itself plus 1. So it's going to add 1 to it. And it's just going to keep doing that until it can't do it anymore. So what it should do is it should end up printing it 5 times. Why? Because the first time I is 0, so it prints I, but then it adds 1 to it, so then it's 1, and it keeps doing it until it hits 5. So when it won't print the 5th time. So see, and that's exactly what it did. It got up to 4, but then once it was 4, then it added 1. It was 5. 5 is not less than 5, so it was false, so it broke the loop. So that's useful for like if you need to repeat something over and over again. Another way you can do this is called a for loop. In many of the more modern languages, for loops don't work the old way where you had like the 3 sections. Instead, the way the for loop works is an iterator. So basically, it's for I, which is my variable, in, meaning in something. So it could be in some sort of collection like an array or whatnot. So for I in, and we're going to create a range. So we'll say I 1 through 7. So when I do that, what it is, it's creating a range of numbers 1 through 7. And it's going to basically iterate through that range. I could make it 2 through 7, and it'll start with 2 and work its way to 7. And then the first time it iterates with 2, and I'm going to use the same code. It's going to do the same thing, except now it's going to start for 2 and end at 7. So let's run that code. And again, basically the way you do a range is, again, you put those two dots between the two numbers that you want the range in between, and it just generates a range. Literally just creates the sequence of numbers. Okay, and see, there it did it. So 0, 1, 2, 3, 4, and then it did 2, 4, 6. So for some reason, okay, it was 2, prints 2, 2 plus 1 would be 3, 3. Oh, that's why. Okay, because what happens is that it's printing I. So then what happens is that since I'm putting this statement in there, it messes everything up because it's editing I before I changes. So if I run that again, then it should behave the way I expected it to. And then after that, we'll kind of delve into collections, like arrays and stuff. Cool. So then there it works. So 0 through 4, that's this loop over here. And then 2 through 7, that's this loop over here. Okay, so those are your two main loops. Okay, so there are three types of collections in Kotlin. And basically, the idea is when you're programming in Kotlin, um, uh, a collection is a collection of data that you might be manipulating. And generally, every programming language has all sorts of ways to manipulate your collections, whether they're called arrays, lists, maps, dictionaries, whatever. So here it's basically lists, sets, and maps are your collection types. So how does this work? Okay, so if I want to create a new list, and list is more like an array, a traditional array, but you would say, and they're all going to be using parentheses for declaration. So new, oh no, I mean var my list. Let me just double check. Should be var, but no, just check. List. Okay, we're actually going to use the val keyword. Okay, because there you're declaring your list. Okay, so it's val. So we're declaring a value, so it must be declaring collection. My list, which is going to equal a list. Oh, REPL's getting angry with me. But I say val my list is equals a list of, and then I can create my list. 1, 2, 3, 4, 5. And with a list, what happens is, let's see here. Let's print line. First, we'll print my list of, so the full list. And then we'll print line. We're only going to print one item from the list. Since it's like an array, it means it's indexed, which means each item in the array has its own index number starting with 0. So technically that 1 is technically index 0. So we're going to print that out. So then technically 2 would be index 1, etc. So let's see if we print those out. If it prints out just fine. Error function, let's see here. List of expected print line, list of Oh, that's not the name of the variable. Dir. Okay. My list. List of is a function. Okay, my list. Let me just make sure my declaration is fine of the list. That's over here. List of, and that looks correct. Okay, so let's run that again. Except I typed it wrong in that one, but yeah, so see there, it printed the first item. Here it didn't print it right because I mistyped it. There we go, my list. So there it would print out the full list, but we see that it's working. Okay, now if I want to do a set, it's basically the same idea. Okay, so we'll call this my set. And this, instead of saying a list of, it's a set of. Okay, and then you can print my set. And you can print my set item 1. What's the big difference then? The difference is that a set cannot have duplicates, which is useful when you're like keeping track of like serial numbers. You want to make sure there's no one has the same serial number twice. So some sort of data where you know everything is unique, or you're keeping track of like a set of crayon colors. You don't need In a list of crayons, you don't need 2 blacks or 2 whites. You just need 1 of each type because you're just referring to that list. So it just depends on, is it a list, like if it's a list of attendants, you might have 2 people with the same name. In that case, a list is probably a better choice. But if it's something where, you're doing first name, last name, so there's probably only going to be 1 of each person, more than likely, then you might prefer a set. So you make sure you don't have duplicates of the same person, because it'll throw you an error if you have duplicates. So let's see here. Should print everything out all the same. And there it goes. Well, none of the following candidates is applicable because the receiver's type mismatched. We're in line. I'm assuming a set doesn't have any kind of order. Let's just double check what it says about sets over here, and I'll put this documentation link in the video description. Okay, set t print line number dot first. Okay, so this is a linked list, so you can only print a first or a second. So technically, what I would want to do is do that. Print the first. So essentially, if I go back over here, what I want to do is print line my set dot first. You only can print the first or the second. I can't just print them all out. Okay, and just pop, and then there's also functions for, like, is it included or whatnot. So that's another distinction between a set. It's not indexed. So that means you can't just call the numbers up through an index like I did with the list. And see there, it calls the first item. So there are functions for you to access the different parts of the list. That's always part of the process of learning a particular new language, to learn all those collection manipulation functions. And the last one is a map. A map is our good old friend, the key value pair. My map. And the way these work, okay, is you're going to have key value pairs. Just make sure that we declare it correctly. So map. Okay, so that's basically what that's going to look like. So what this is, you're just saying this key matches this keys is linked to this value here, and you're creating a list, kind of like creating like a little mini record. So in this case, just to show you sort of a good example of how it would be useful, you might say, hey, the key name goes to the value of Alex Merced, my name. Okay, and then the name or the age key goes to, we'll say, the string of 34 to make sure that all the keys have the same type, 34, because oftentimes languages will complain when that's not the case. Okay, so name links to Alex Merced, age links to 34. Okay, and then we're going to print out my set. Okay, and I'm going to assume that you call it by the key if you want to call an individual item. So we're going to try that out. If not, well, then we'll peek. Okay. Error type mismatch inferred, type string, but int was expected. Why was an int expected? Oh, doesn't it say this should be my map, and this should be my map. Okay, let's run that again. Okay, the dangers of copy and paste. Okay, so that basically how map works. So there is my map, mapping all my keys to values. And then if I want to bring up the value of my name, I just call up the key, my name, from the map, and it brings up that value. So that's pretty much that. We'll do more in the next video, but I think we've done plenty in this video talking about all sorts of good stuff. So I'll see you guys soon. We'll talk more about Kotlin. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.